All right, so my name is Jamal Ashraf, and I want to cover the second part of searching algorithm. I want to talk about the recursion and how is it going to apply to binary search. In the previous video, I covered the linear search and binary search, but we use the iterative way of doing the binary search. I want to get into recursive, especially if you're coming in from another class that didn't spend too much time on recursive. I think we need to spend a little bit time on recursive and learn it to our advantage. So I'm going to share my screen, and I am going to do my PowerPoint over here. And I'm going to swap the presenters. Okay, so today we're going to be talking about recursion. So basically what we do about recursion is we have a task, and we're going to take that task and we're going to break it down to the smaller task, but every task is going to be the same as before, but with a little bit of a modification to it. So we have a base case. The base case is where we're going to stop. So one of the biggest problems that we're going to have in recursion is if we don't have a stopping point, then we are going to be running it all the time till we run out of the memory. Recursion is going to take a lot of memory. Everything's going to be in the memory. We're going to talk about it. And if we don't stop it sometimes, or if our program is going to be using a lot of memory, eventually you can run out of the memory. The newer operating systems are going to stop your program and it's going to give you some kind of a memory fragmentation. The older computers would crash because it doesn't have no memory anymore. So that would be the base case. And the recursive steps are going to be steps that we need to go to make it smaller and then call itself. So that's what we're supposed to do. The example here, we're going to go with a small example to see if we can understand this. In this case, we are talking about triangle numbers. So we have the lengths 4. Every one of them has an area of 1. So if I have lengths 1, my area is 1. If I have lengths 2, my area is going to be 3. So that's what we are using. So we have, so if I go to the length 3 is going to be 1 plus 2, that's 3 plus 3 is going to be 6. And if I go to length 4 is going to be 6 plus 4, that's going to be 20. So this is the problem that we are trying to solve. And that's what we have. And we want to apply the recursion on this to see how we're going to do it. So first thing we're going to do is we're going to define where we're going to stop. So the stopping point is what we're going to be concentrating on the first part. So we're going to say, okay, if my length is 1, then the area is 1. That's what we're going to stop. As soon as we see a length 1, we're going to return 1 and we're going to stop. We are using a method or function for this. So here we say the area that we want to try to figure out. Remember, if I am on length 4, I am going to get the smaller area. So I'm going to get the area of the smaller one, and then I'm going to add 4 to it. So the area, this is the way we're going to be thinking to go into recursive. So the area of length 4 is the area of the length 3 plus 4. So we say the smaller area plus the side lengths. So that's what the area is. So what do we need to do? We're going to calculate the length of the smaller one, and then we call the same function again with the smaller area. So in this example, side length is 4. The area is a smaller area plus 4, which is the side length of 3, so it's going to be 6 plus 4, that's 10. So this is a small code, and I can show you the actual code in PyCharm. I'm using PyCharm for this. So if the side length is 1, we're going to return 1. Otherwise, of course, we don't need this else, because if it doesn't return 1, it's going to come down here anyway. But to organize it, I put the else in there. So we're going to calculate the smaller side. That would be the side length minus 1. Then we're going to calculate the smaller area. That's going to be the triangle smallest side length. And then we're going to calculate the area, and we're going to return area. Now, the way this is going to happen is because we're calling the same method again and again and again, what's going to happen is going to come down here. And when it calls itself, this is going to stay in the memory with the smaller one. So we start in this case with 4, we go to 3, then we go to 2, then we go to 1. These are all, they call it the stack. It's going to stack up on the memory. Then when it gets to 1, it's going to return. Then it's going to return 1. Then we're going to take the 1, and then we're going to add it to the other one, and we're going to keep doing this. So first it's going to go to this area, then it's going to go to this area to calculate the whole thing. So that's what the recursion is about. So let's see how this is going to work out. So we're going to call the area with 4, and then the 4 is going to create the 3. Then we're going to call the 3 is going to call the 2, then we're going to call 2, the 2 is going to call 1, and we know what's going to happen with the 1. That's going to return 1 from us. So right now I have the area of 1. Now it's going to backtrack, and it's going to go back to the smaller area plus side lengths. That would be 1 plus 2, that's going to give me 3. Then it's going to go back up for 3 plus 3, that's going to give me 6. And it's going to go back up, and that's going to add 6 plus 4, that's going to be 10. So all the way down here is going to be inside the memory, and it's going to stay in the memory. That's why recursion is memory extensive. It's using a lot of memory. So my computer should be up in line with the memory. So the idea of the recursive computation is to solve a problem that's going to be using the same problem with simpler input. So we have the same problem with the simpler input. So one of the things that it says over here, it says, do not think about it. We don't have to really get to the detail of how these things are happening. We just got to practice on it, learn it. There are some stuff that we can do iterative, as we saw the binary search, which is not memory extensive, but there are going to be some algorithms that you cannot do it without recursive. So you have to use recursive, and we're going to see it as we go through this class. So every recursive call must simplify the computation in the same way, and we have to be sure we're going to handle the simplest computation. Otherwise, it's going to run forever. So when we have a problem, especially with this class, we're going to be thinking about the best algorithm. So sometimes we don't have to make it too complex. We can just come up with a way of doing it. So we can use a for loop. We could use a while loop, or you saw it, I have it in my previous recording that we did it through iteration, to the loop. And then, some people might think about it as a mathematical equation. So I can just put this equation to calculate this. I don't really need to go through all this algorithm. So we got to think about these things. This is the class that we got to think about these things. Of course, the next class after this would be software engineering, that we're going to be calculating the performance of the programs. Right now, in this section or this area, we are calculating the performance of one method or function. So this would be a one that is going to be running. Let me show you the code that I wrote for it. It's very similar to this. So what is my? So this would be, so the way I do it is I create a, let me make it a little bigger if I can. So I have my function over here. My first part is to check for the one. Then I would calculate my smaller one, and then I call the same function with the smaller one. So it's going to keep calling itself. And then after that, I'm going to calculate the area and I'm going to return it. So that's the program. And if I run it, it's going to run it and going to give me 6 for the area of 3. And then we run it for area of 4, and it should give us 10. So that's what I have for this one. Another way of doing this, which is something that I'm going to be focusing on our Java advanced data structure, that we're going to be using classes instead of methods. So we can use objects instead of it. I don't think it's going to be in the scope of this class, but if you guys want to spend time to figure it out, that is a good thing to do. So we can create a class to do this, and then we have a site length as a instance variable, and then we can put the code in there, in a method in there, and then we're going to be calling the object instead of calling the method. So the most common error would be the infinite recursion. That means that we create some kind of algorithm that's going to be running forever, or it's going to be so much memory extensive that we're going to be running out of we can potentially do that with the recursion, that we can run out of the memory. So if I have a lot of calculation, a lot of things in there, then it can potentially run out of the memory. So the last part is what we're going to do. We're going to use the binary search recursion. I will make another video for more advanced recursion for those who are interested to take a look at it, to do a little more advanced stuff in recursion. But here we just want to use it for our data structure, which is our binary search. So remember about the binary search. The binary search, it looks for the middle of the list, and if that middle one is what I'm looking for, I am good. If that middle one is not what I'm looking for, I'm going to check the middle one against the value I'm looking for, and either I'm going to go to the left or I'm going to go to the right. And I keep doing that till either find what I'm looking for or find out that the element is not there. So we have this, we did it in loop format in the previous video, and this is what we're going to do in our lecture format. So what it is doing is, for those people who don't know, is we can have default values in our functions. So when we have default values, means I can call this method with only 2 parameters. It's going to take the 0 for this, and it's going to take none for this one. So that's what we're going to put the default value, so we be able, or the user doesn't need to know about the low and high. That would be the beginning and the end of what I'm searching. So first thing first, if my high is none, basically if they didn't put anything for the high, I'm just going to do the length minus 1. That's going to be the highest point that I have, the last index of my list. And then the next one is we're going to be checking for low to be greater than high. So either we overlapped it or we're going to have an empty list. That's going to return -1. -1 is an acceptable index for Python. That's why some people don't use -1, but I'm coming in from different languages, C++ and Java, and -1 is kind of a standard way of returning. So, and your book is using -1 also, but that's what it is for now. And my function is going to tell the user that's the way it is, and that's the way they can use it. So we're doing the integer division over here. We're going to add the low plus high divided by 2. This is integer division, meaning that we are not going to get a decimal point. We're just going to get the integer. So 7 divided by 2 is going to give me 3. It's not going to give me 3.5. So when we find the mid part, we're going to check it to see if it's the same as my target. If that's the case, I'm going to return. So this part is just exactly like the part we talked in the loop section. Now, if the target is less than my midpoint, then I'm going to go to the left. And that means I'm going to take my high, my end of the right, I'm going to move it to the middle -1. So I'm going to grab the left side of the list. If my target is greater than the midpoint, I'm going to grab the right side of the list. And I'm going to keep doing this. So I'm going to keep breaking down, break it down. I kind of created a good animation type in my last video about how does this work. You might want to go back and take a look at it if you don't know what I'm talking about. So to go to the right side, we're going to start my low at mid +1, middle +1, and then I go to the high. And this can be adjusted as we go through it. So when we do something like this, we want to test it. And the way that we're going to be testing it, we want to put some numbers in there and try it out. So we would have some kind of a list. Of course, it's going to be a small list for our practice to use it. As I said in the previous video, binary would work best with large number of elements in the list. So we are calling this binary search method, and then we're going to get the result. We check it to see if it's not -1, we're going to return the index. So that would be the index of where I find it. So if I have 7, it should be 0, 1, 2, 3, index 3. If I have different numbers, then it would say if it's not in the list, it's going to say not found. So the things that we have to consider is when we are testing, we have to test all kind of scenarios. So if I have this method, I want to be sure it's tested correctly, I have to find the scenarios and then figure out what else do I need to check. So first, of course, we want to check to see if the element is in the list, is going to return the correct index. 2 is, what about if the element is not there? It has to return element not found. And the third one we have to always check is, what about if the list is empty? What about if somebody gave me an empty list? Is that going to work with this method that I have or not? So I made the program. Too many things on my screen. Where did they go? Let me pause. Okay, so I wrote this in PyCharm again. So we are using a main, the way that I like to do things. I always put the main on the top, because when you are writing program all over the place, you have lots of methods. Then you want to have your main on the top, and then we're going to have these things at the bottom. That's going to say if main equal main equal main, meaning that this one can be as a part of another module. So if this one is a part of another module, it's not going to execute the main. But if it's not part of the module, another module, when I'm testing it myself, it's going to call the main. But they can put this one into another module to call it in somewhere else, and it wouldn't call main because the other module would be main, not this one. So this is the binary search recursion. I have 4 parameters. So we are starting with 0 and none. We go with the high equal length -1 and so on and so forth. We talked about this already. So I have 3 scenarios I want to test. So I took this list. I'm going to put 9 in there. The 9 should give me 1, 0, 1, 2, 3, 4. So the first one should give me index 4. And then if I test it with 12, which is not in the list, it should give me not found. And then what's going to happen if it's not the in the list? So meaning that if I had an empty list, what I'm going to do? I could potentially check the empty list and return it at the beginning, but we can talk about the empty list. So if I receive an empty list, this empty list is going to be going in here. So when it's empty list, my high is going to go with the length -1. The length is going to be 0, -1 is going to give me -1. So in this case, my high is -1 and my low is 0. And it's going to check here. It says, okay, low is 0, that's higher than -1. So it's going to return -1 and it's going to say your target didn't find. It's not telling you that the list is empty. It's just going to say the target didn't find. So that's the way this one is created. So if I run this program, that's what I get. The first one is going to be on index 4, and the other 2 is going to say